Welcome students. In this session, we will look at the concepts of max pooling layer, which is the second part of the convolutional neural network. So as you would have noticed in my previous videos, you would have found that all the data are not necessary for taking a decision. We say the concept of feature selection is very necessary to make sure that the dimensionality exponential increasing problem is not encountered in the deep learning methods. So how can I use a feature selection method in my CNN? The answer is your max pooling layer. So it will find out if there is any useful information from the features extracted using the convolutional layer. If it finds that there is no meaningful features in the output or in the data, then those information will be removed. If you would have closely observed my videos, you would have seen the boy sitting on a duck image. You can find out that only in around 20 to 30 images you can find the body parts of the child, but in other images you will not find any body parts, in the sense that other images are not relevant for decision making. So now how can I find out that whether my feature extracted is having some useful information or not? That can be detected based on the output of the convolutional layer. You can see here two convolutional operations. One, you can see clearly a mismatch between the filter and the original image. Note down the filter in the first image. You can see 30 in a L-shaped direction, but everything else are 0. Now, when this number is multiplied with my original image, you can find that you will find plenty of data, or the number is quite large. But when you look at the other image, you can find that the 0 position is not aligned with the 30 data. So what happens is, when you multiply, the answer is 0. Whenever you get a value of 0 in the output of convolutional layer, you can say that the information is not available. So the idea or the clue here is, note down the convolution layer outputs. If you find a value of 0, or if it is less, then you can remove them. Otherwise, you retain them. This can be also assumed as a downsampling technique. If it is 0, you can straight away reject or remove the features. But if it is not 0, what should I do? Say for example, you are facing a situation with 30, 40, 50, 60 values. What should I do? So in that case, you can choose a dimension of your choice. In this example, you can see several quadrants where each quadrant is having 4 features. The circled one are with the highest value of the features. So those features will be retained, and all the other 3 will be removed. In this case, you can see a feature reduction of 1:4 is obtained through the max pooling layer. So this reduces size of the array. So the probability of having a practically feasible method is more if you follow this concept of max pooling. And the third part, as we have already discussed, is the fully connected layer. It is a normal artificial neural network where you go for input layer, hidden layer, and output layer, the concept of weights, and also the training process with the help of stochastic gradient descent. Now, this is all about architecture of the convolutional neural network. Now, let us look at the training part of the convolutional neural network. The training part consists of two passes. One is the forward pass and the other one is the reverse pass. Let us see what happens in the forward pass. The filter parameters are randomly initialized. Now, the complexity in the training of CNN is that you need to adjust two parameters. Apart from your filter parameters, you need to also adjust the weights of the hidden layers in your fully connected neural network. So first initialize your filter parameters. Now pass it through the convolution layer. Calculate the convolution layer outputs as we have already seen. Now pass it through the max pooling layers. Downsize your data. Now depending upon the combination of convolution layer and max pooling layer, continuously repeat the process till you reach the fully connected layer, where we convert our two-dimensional data into a one-dimensional data, because The output of max pooling layer is 2D image, but the input layer of FCN is a single column. So here we again make use of net value calculation and softmax activation function calculation. And as we all know, CNN falls under the category of supervised learning methodology. So the error value is calculated using the outputs and the targets. Now comes the reverse pass. So what happens in the reverse pass? There is no adjustment process in the forward pass, only the error estimation. Now based on this error, we come back and adjust our parameters. So what are the parameters we are going to adjust? The first is the weights of the fully connected layer. Once the weights are adjusted, it is forwarded much more before the error network, and the filter parameters are again adjusted. How do we do that? Using the gradient descent algorithm, which is a very common algorithm. However, it can be used only when the error value is not zero. If it is zero, or if you feel it is close to zero, you can say that your initialization of weights and filter parameters are correct. Now it passes to the convolution layer to adjust the filter parameters, and this process is repeat for a specified number of iterations till we reach an error value of zero. The formula for error is output minus target should be equal to your error. Once trained, now you can take the filter parameters, you can take the weights, the training process is over. Now the testing process is done one by one. You can take any input data, supply it to the network with the already predefined filter parameters and the weights, and calculate the output. You will find out that you are getting the best possible output when you have a good convergence.